Okay, so let's jump on to the quiz. Okay, so here's the quiz. And we have two things to do. So actually, let me copy and paste. Okay, so part A is we want to find dy dx if y equals e to the 3x times ln of x. So what rules do we have to use to find this derivative? Not a trick question. Yeah, product rule, and it turns out chain rule too. So what I'm going to do is I am going to copy this, makes it easier, and then adjust. All right, so we got y equals e to the x ln of x. So y prime, and with the product rule, you have an addition. So I can write plus, and just for now, pop it in. And now let's go change them. So what's the derivative of e to the 3x? What's the derivative of e to the 3x?
Is it 3e to the 3x?
Exactly, because we use a chain rule. And the derivative of 3x is 3. And the derivative of e to something is e to the something. So that's just 3e to the 3x. What's the derivative of ln of x?
One over x.
Yep. So it's just e to the 3x times 1 over x, which I'll write as e to the 3x over 1 over x. Or over x. E to the 3x over x. And there's the derivative. Any questions? Any questions on finding this derivative? Any questions? Okay, let's look at part B. So part B says use logarithmic differentiation to find the derivative of y equals x squared e to the x times the square root of 2x minus 1 divided by x plus 1 to the 7th times the square root of x plus 5. All right, just let you know that if you didn't follow the instructions and you use the product and quotient rule, you're not going to finish in the 15 minutes that the 20 minutes you're given. This would be a nightmare. Do you all agree? This would be a nightmare to try and use the product and quotient rule with all these products and quotients. So what is the step on using logarithmic differentiation? What's the first step? Remember? It's the very last example I gave on Monday. If no one remembers, that's going to be scary when I'm grading this. Yeah, we take the ln of both sides. You can write natural log, but everyone writes ln, a lot less like typing. So we're going to take ln, and then we're going to take ln of that. And now we go and deal with this ln of this big quotient product stuff. And the idea is that you can use the rules of logarithms that says that if it's multiplying, you're adding, and if it's dividing, you're subtracting. And exponents can go outside. So ln of x squared is 2 ln of x. What's ln of e to the x? Hint is really easy.
E to the x.
Easier. Not as easy as 1, but still easy. ln of e to the x is, by definition, actually, it's 1. I mean, sorry, it's x. That's what happens when I look at something and try to say something else. So ln of e to the x is x because that's f inverse of f of x is always x by definition. Okay. Oh, your mic doesn't work? Okay, well, the chat box works then, if your mic doesn't. Here's the secret. Get these super mics that I got. Okay, so we have plus x, and then we have the square root of 2x minus 1. And you want to think of the square root, if you remember, as a power. And that's the 1/2 power, so the 1/2 can go outside. And then we're going to have ln of 2x minus 1. All right, let's do some more. Then we have on the bottom, x plus 1 to the 7th. And remember, you subtract if it's a division. So it's minus 7 ln of x plus 1. And then similarly, when you have a square root, that becomes a half. And it's minus because we're dividing. 1/2 times ln of x plus 5. And now that I've used it, I can get rid of the middle step. So let me stop. Any questions at all on the first step? All right, let's save that one for now. And now it's time to find a derivative. And we use implicit differentiation to do that. What's the derivative of ln of y? Yeah, y prime over y, usually lowercase, but I'll let it happen. So it's y prime over y. And then what's the derivative of ln of x? That's 1 over x, so we can write it as 2 over x. Derivative of x, you better all know by heart. That's just 1. Now the derivative of ln of 2x, that's a chain rule. That's 2 over 2x minus 1. 2 times 1/2 is 1. So you just get 1 over 2x minus 1. And then the derivative of ln of x plus 1 is 1 over x plus 1. So we get 7 over x plus 1. And the derivative of ln of x plus 5 is 1 over x plus 5. Right? If you want to use the chain rules times 1. So that's going to be 1 over 2 times x plus 5. Like so. Any questions so far? Okay, then just so I don't have to type so much, just going to grab the, actually, before I do that, let me not grab it yet. Let me copy this. Now let me grab this guy. Just grabbing y. Okay, we want y prime. So what do we have to do to both sides? Nice and easy.
Times it by y?
Yeah, times it by y. So I'm going to write y prime. Do you have to take a derivative if there is one? Like on 1 over 2x minus 1, it would be 2 over 2x minus 1 because the derivative of 2x equals 2. Right. Now I did that, but if you remember, there was a half outside of that. So I did the 1/2 times 2, which gave you 1. Does that make sense? So that happened in kind of 2 steps, but I wrote it down as a single. Okay, so what I'm gonna do is I'm gonna multiply by the y. That's why I copied and pasted before. And now just to make it pretty, I have to take this guy and put it in the parentheses. And there's the answer. Okay. How long would this take if you didn't use logarithmic differentiation? Do you think any of you could have done this in the 20 minutes of the quiz? Yeah, I don't think so. Okay. And by the way, how long do you think it would take if you had to use a limit definition? Yeah, that would probably take weeks. Yeah, even longer, more than even longer. That would be like weeks of your life. Okay. In fact, the easiest way to do it would be to prove all the theorems and then use limit def and then use them. So don't even think about limit definition, but also don't even think about doing product and quotient rule a zillion times. That's a bad idea. Whereas it's only took about 5 minutes to do, you know, given that I'm pretty fast at knowing copying, pasting. And hopefully as we're getting through the course, you're going to get faster too, because it really makes a difference. Any questions at all on this quiz? Okay. Just, I should let you know, because there were some complaints about, you know, I haven't seen these problems on the, so a couple things. One is I write the quiz after I give the lecture, sometimes a couple hours after, but sometimes right out, you know, usually I grade your homework and then write the quiz. And which means it's fresh in my mind, the examples I gave in class. So if you're going to be studying for the quiz, definitely look at the problems that I gave in class, because that's fresh in my mind. Okay. Whereas the homework, some of the problems, most of the problems I didn't even write. So, you know, that was my team. I wrote a few of them. Okay. But this stuff was well practiced in the homework anyway. Yeah. Calculus is pretty standard. Okay. But I want to let you know that, you know, I try and, you know, I've just done the lecture. So then it's time to think about the examples that I gave. And you know, they're not exactly the same, but same ideas. All right. Let's go to our things to do today. Are there any questions about anything right now? Any questions? Give you a second to think. Okay, well, if you don't have any questions, I do let you know, make sure you put your thinking cap on. And I also recommend getting pencil and paper out so that you can take notes and see if you can, this is something I did. It was my technique when I was a student, okay, all the way down, I mean, from childhood all the way up to college, is I always tried to be one step ahead of the teacher. So let's see if you can do the same thing. And then if you end up, you know, getting it wrong, that's okay. Then you cross it out and you write down the teacher wrote. So my challenge is to see if you can do the same, especially after the first example I give, is that because then you're thinking a lot more, you're practicing and you're writing and you'll remember it more. So that's just a suggestion for studying. And that's in math or science, any of those classes, be one step ahead. I think if it was an English class, I don't know if you can really be a step ahead in English. It doesn't quite work that way because it's not step by step, but math is. All right, so here's the deal. There is no theory to talk about. I'm not going to write down theorem. I'm not going to write down formula and highlight it and do that kind of stuff, because that's not what we're doing today. Today is word problems, and that's it. So there is nothing to talk about in terms of new material at all. But we haven't done very many word problems. I mean, if you look at all the quizzes, I think I gave you one word problem on a part B, or it might have been number 2, I don't remember, for one of the quizzes in the entire 5 weeks of class, or 5.5 weeks. Everything changes starting today. So you can think about the first half of the class is how do you take a derivative? Does it feel that way, that that's what we've been doing and that's all we've been doing? The second half of the class is how do you use the derivative? So today is our first main day of how to use the derivative. Okay, we did talk a little bit about velocity and acceleration. We did that, but now we're really getting into it. And what I have is I have a bunch of example questions, and we're going to go through the example questions and practice. And that's the only way you can learn this stuff is practice. It's not the kind of thing where flashcards are going to help at all. Just let you know that. The only thing you can do is practice. And that's why you want to make sure that you're writing it down. Otherwise, you're watching and not practicing, because that's how word problems are. Okay, so what I have is I have an example question. And what I'm going to do for this one, I won't do it for the others. I'll say them, but I won't write it out, is I'm going to kind of write down the kind of step-by-step suggestions on thought process. It's not a math step-by-step, it's thought process step-by-step. So step 1. This is going to be very obvious. What haven't we done yet? What haven't I done yet? This is obvious.
Read the word problem.
Exactly. Read the question. Read the problem question. And I'm going to write down an important word carefully. So force yourself to read slowly and to read every single word. Because sometimes if you miss one word, it'll destroy you. Okay, now I didn't do this, but one of the things you'll see on some trick questions, I don't give trick questions, but homework could. Sometimes the units don't even match. And if you're not careful, you won't even notice. Okay, but I try to make my units match, but sometimes you won't see them matching in like homework problems and stuff. I will give you a example that cost, so it was a mistake that my friend made. It was my friend's husband. She was a professor in math at Sonoma State. It was a long time ago. And it cost his group over $100 million because of not reading the units right. Anyone know what that was? He was in charge of a Mars landing, and he had 2 groups. One group was using the metric system, and one group was using our system. And then the parachute or whatever it was opened up at the wrong time, and it crashed. And that was the end of the whole project. And it was $100 million because he didn't read carefully the units. Okay, he was also rushed because of money, believe it or not. 100 million isn't that much when it comes to a big NASA expedition. But very important. And in engineering, it could kill someone if you don't read the question right. Okay, because if you construct something wrong, like a bridge, and someone's driving over and it collapsed because you were doing it in meters instead of feet, you killed someone. So don't kill anyone. Okay, so in this example, you're not going to kill anyone, but still you could get it, you could get it wrong if you don't read it. Okay, so suppose a bird is flying horizontally 20 meters above your head at 7 meters per second. How fast is the angle of elevation changing when your horizontal distance from the bird is 10 meters? Okay, can you imagine this in your head? Right? You got a bird flying above you somewhere, right? And it's flying, you know how fast it's flying? And you want to find out how you want to turn your head so you can watch it. And let me give you a true application. I mean, it's kind of fun, but you probably wouldn't do calculus to turn your head. You'd probably just turn your head and watch the bird. But who would have to do calculus for a very similar problem? And I know we have a couple of you in this major, actually, or similar major. Any ideas? Artificial intelligence programmers. Because what you do is you have a camera, you have a computer, and you have to watch whatever it is you're watching, let's say self-driving cars, so that you can notice what's going around along you. And then you got to see, well, how fast you need to change the camera to follow whatever's going on. And you have to program it before it even happens. Okay, this stuff happens. And if you can, by the way, if you can learn this really well, then if someone offers you $100,000 a year, laugh at them, because that's not enough money. That's how much money these people make. So if you want to make the big money, this is where you make it. Okay, my nephew actually, I think he's worth about $10 million right now, and he's, I think, 29 years old, and that's what he does. He does artificial intelligence stuff and does businesses for it. So you make big, that's where the big money is right now if you're looking for it, just let you know. So this is a kind of the new way of thinking about it, because honestly, you're not going to use calculus when you do it in your head, you know, just to watch a bird, but you will if you're an engineer, to make a computer and a camera watch a bird. Do you see the difference? Okay, so that's step one. I read it carefully. I can imagine it. Step two. Step two is, if applicable, draw a picture. Okay, that helps a lot, because you can get a kind of a view of what's going on. And it just makes it easier to see than to read a whole paragraph. It kind of puts all the information in a picture. Any questions so far? Okay, so just a note, I'm going to draw it on paper and then I'll show it to you. But if I don't draw it on paper first, I won't remember the paragraph. So I'm going to do it. And maybe you could do it as I'm doing it. I'm not going to say anything as I do it. But we have a bird flying horizontally 20 meters above your head. So there's me. I'm a dot. The bird is also a dot, which is fine. You can make a little picture of a person and a bird if you want. Dots are fine. Okay. And it's horizontally. Distance is 20. The bird is flying. Okay. At 7 meters per second. Okay. And we want to find out the angle of elevation changing. Okay, so now that I've got it at least on paper, now hopefully you have it on paper, but now I'm going to just show you. So let's insert a drawing. So we have a bird and we have a person. Okay, and let's draw the person, maybe as a dot or circle. Okay, the good thing is I'm such a bad artist, that's a person. The bird is flying overhead, okay? Not necessarily right above my head, but somewhere. There's the bird. Looks just like a bird, doesn't it? Okay. And what I want to do is I want to look at the angle of elevation. And we know that it is above my head by 20 meters. Okay, that's not the distance from me to the bird. What is that? If it's 20 meters above me, what's that distance? It's not from me to the bird. What is that 20? Okay.
And if you drew a triangle, it would be the opposite side, wouldn't it be? Or I don't know what
Yeah,
you're looking for, but yeah, it's the
Yeah,
vertical
in
distance.
particular, it would be the distance. It would be the distance from me to the straight above me and the same height as the bird. So, oops, that one. So it's going to be this guy. So there's my 20. And then just so that I can have this bird, we're going to do that and that. So again, you can draw a triangle and a right triangle, not just any old triangle. And then we're going to put in our numbers. 20. Is 20 changing, or is that 20 going to be the same while the bird is flying and 10 seconds later? Is the 20 something that's changing or not changing? Yeah, 20 is a constant. The bird is flying horizontally, and that's important. If the bird was not flying horizontally, that 20 is changing. So I want to let you know when you draw the picture, only draw the part of the picture in terms of numbers that's not changing. Got it? Okay. And that's going to matter later. In this example, it doesn't, but later it's going to matter. Any questions so far? Okay. We want the angle of elevation. What's the angle of elevation? That's an interesting one. So from the right angle, is it below or to the right?
Below.
So do you all agree it's below? Tell you what, I'll give you one more guess. So the angle of elevation is the angle from the horizontal, not the angle from the vertical. So the angle of elevation is actually this guy, which is obvious. Technically, it would be this one here, right here, not inside the triangle, but outside. But then from basic geometry, we know that this angle here is the same as this angle up here. So we want to know that angle. So that's our question. We want to find out how fast that angle is changing. Any questions on that? Let's give it a name. I'd call it theta, except I don't know if I could type theta with this program. So I don't know. How about A for angle? Sound good? Since unfortunately theta is not available in this program. Okay. What else is changing besides the angle as the bird is flying?
The distance between the bird and you.
Okay, good. The distance between the bird and me. And maybe I'll call that H for hypotenuse. Sound good? And what else is changing?
The horizontal distance.
Yeah, horizontal distance. I'm going to call that X because X is usually what you use for horizontal, right? Any questions on the picture? So again, it's very important to make sure that the 20, because it's a constant, doesn't change as the bird is flying. That one's there. But later we'll have some that aren't going to be there. Okay, so now, oh no. This happens sometimes and I don't know why. But it crashed. I think what I can do, I have an idea. Just a second. I think you can't see what I'm doing, but that's okay. Ah, shoot. That's what I want. Let me try this. Nope. Okay. So unfortunately, we're losing it, but we'll get it back. That's what you call technology. Sometimes it does weird things. All I have left is a dot, but that's okay because I used snipping tools and I got it back. Okay, so that's step 2. Any questions on that? Okay, ready for step 3. I'd say step 2 applies about 85% of the time. There's sometimes there just isn't any picture. It doesn't make sense. Sometimes, especially like in economic stuff, where what's changing is money and it's not a geometry thing at all. But in this case, it definitely did happen. Step 3, write down the equations that come from the picture and the words. All right, so let's see what we have. Okay, we want to find out. It's always good to say, what do you want to find out? We want to find out how the angle A is changing. Is that clear? Now I want to remind you, what am I calling this section? And not me, but the book, but everyone else in the world too. What's the name of it, of the topic today?
The rate of change.
Not quite. Yeah, related rates. So what you do to do related rates is first you do related non-rates, related variables. Then you can go and do related rates. So notice we're given that it's flying horizontally at 7 meters per second. What is that? What's the equation for that? Here's a hint. Think calculus. Because it's meters per second, which is a speed.
The first derivative.
Yeah, but that's not enough. Because we have an A, we have an X, we have an H. So Leibniz notation is necessary. It's D something over D something. What is it? And in fact, since you're not getting that, I think I'm gonna make that step 4 because you're not ready for it yet. I'm noticing. So let me go to step 3 to kind of ease you in. Step 3, write down the derivative that you know and the derivative, sometimes there'll be more than one, that you want. Okay, so the derivative that we know it's going at 7 meters per second. Okay. When you say dy dx, well, what's y for one thing? I'm looking at the picture, I don't see a y. And it really helps to look at the units. The units here are meters per second. And remember, derivatives are fractions also. It works the same way. So 7 meters, what does that correspond to? X, A, or H? So after a second, has X changed by 7, A changed by 7, or H changed by 7? Yeah, X. So that means that in terms of what's given, the numerator is dx. Per second, what's the denominator? The hint is it's not in the picture. You usually don't call it y. Everyone calls it by the same letter, dt. Whenever you're talking time, everyone in the world uses t. Okay, and not for some tricky way. I think it's kind of obvious why you use t for time. I hope you all can get that. Okay, so I'm going to write dx over dt equals question mark, because that's our question. Okay, that's the derivative we want. Any questions on that? I'm sorry, that's not a question. Sorry about that. That was a mistake. We know that one. That was a 7. Which is a derivative that we want?
Is it the change in the horizontal angle? Or is that
I
we'll
need,
kind of get
I need
into
letters.
Oh,
D
yeah,
something
I
over D
have
something.
no idea.
Yeah, it's D something over D something. It might help to read the question again. And the question is, how fast is the angle of elevation changing? That's the question. So how fast is the angle of elevation changing? So what
Did you
is
take the
that?
inverse tangent or?
Now you're making it way too hard. It's D something over D something. And what letters? When you hear how fast, what's the bottom for sure? Yeah, it's dA over dt. Okay. How fast is time? It's always per second when you're doing fast, right? Meters per second. And, or in this case, radians per second because it's an angle. And the angle is A. So I'm going to write dx dt is equal to 7, dA dt equals question mark. So let me ask you, is there anyone that doesn't understand how I got that? Okay, so now step 4, and I'm going to add more words to step 4. So write down equations that come from the picture and the words that relate the variables from step 3. Okay, so in particular, the variables from step 3 are that are different are x and a. So we need to find a equation that relates a and x. What is that equation? Don't think calculus. Think pre-calculus. What's the equation that relates x and a?
Sine.
Yeah, in particular, so it's sine. That's the function. But what about the equation? So sine of something. I think I need to still see it. So definitely sine. But what about sine? Yeah, good. So it's sine of A equals 20 over X, because that's SOHCAHTOA. The first three letters of SOHCAHTOA is sine of the angle is the opposite over the adjacent. Oh, wait, sorry. I shouldn't have listened to you. It's true it's 20 over H, but we don't care about H. We
It'd
care
be
about
tangent
X.
of
So it's tangent. Yep. Sometimes I'll listen to you and say yes, and that's not always right. That's my biggest flaw, by the way, in teaching is I don't notice that you made a mistake. So it's a tangent of A equals 20 over X. Okay, any questions so far? Okay, step 5. Implicitly differentiate with respect to t. And it'll just about always be t because rates are usually by time. Any questions on what step 5 statement is? Okay, so now let's start with tangent of A. What's the derivative of tangent of A? You're supposed to have this memorized.
Secant squared A.
squared.
Right. Well, it starts with secant squared. Oops. But then it's by respect to t, not with respect to A. So remember, you have to multiply. So times dA over dt. Any questions on that? Okay, what's the derivative of 20 over x with respect to t? Give you a hint. Starts out with a negative.
Would be negative 10 x to the negative 1/2 power. Oh, wait, no, never mind. That's
Yeah,
brain
remember
fart.
20 over x is 20 times x to the negative 1, not 1/2.
Yeah. So it's negative 10 over x squared.
I'm not sure you're getting the 10.
Nah, I don't know either. I'm just gonna stop.
Yeah, don't divide by 2 because there's no 2 in this one.
It would be
At
negative
least-
20 over x squared.
Yeah, it's negative 20 over x squared. Does that make sense? Because
Yeah, I was taking the 1/2 still. I was thinking it was a square root. I messed up.
that square root is still in your head. That'll happen. Okay, so negative 20 over x squared. But then times dx over dt because we're implicitly differentiating. Any questions on that? Okay, now just want to make sure. What haven't I used yet in this problem? I probably should have noted it earlier to make sure you don't make a common mistake. But what haven't I used yet? I'll let you read the paragraph again. Yeah, haven't used the 10 yet. Okay. It's not H though. I know it feels like H should stand for horizontal, but H stood for hypotenuse. Sorry about that. Okay. So I want to mention something because it's a common mistake, and I'll make sure you don't make the mistake. I didn't, but you could. Is that we have this 10, don't put a 10 here instead of an X. Because as the bird flies, that 10 changes. Do you see that? If you kind of picture the bird moving, if you wait a little while, it's not going to be 10 anymore. Okay, whereas a 20 doesn't change. That's why 20 is in the picture, 10 is not in the picture. Okay, so now we know that X is 10, and that's where we're going to go step 6. That's plug in all the numbers. And it's important you do that in step 6 and not in step like 2 or 3 or something. Okay, so now you plug in the numbers, whether it's changing or not, because once you've taken the derivative, then you can plug in. You can never plug in before you take the derivative if you have a number that's changing. All right, so let's do that. And what I'm going to do is I'm going to copy the equation. All right, secant squared of A. Okay, secant squared of the angle. Okay, we can now go in and realize we have numbers now. X now is known. X now is 10. Okay, do we know H? Yeah, we find it. How do we find H? Think Greek.
Pythagorean.
Yeah, we use the Pythagorean theorem. So H is going to be the square root of 20 squared plus 10 squared, which is 10 times the square root of 5. Okay, you could write it down or do it in your head, whatever works for you. So note that X is 10, H is 10 times the square root of 5. The secant is 1 over the cosine, which is the hypotenuse over the adjacent. So that's going to be 10 root 5 over 10, which is just root 5. Root 5 squared is 5. Was that too much without writing, or did you follow that? Too much without writing? Okay, that happens sometimes. But let me do it next to the picture because I think it's easier. So X equals 10, that's given. H equals the square root using the Pythagorean theorem of 20 squared plus 10 squared. Which is 10 root 5. Just simplifies nicely, somewhat nicely. And then secant of A is equal to...
Larry, you're below the line.
Ah, thanks. Yep. Always let me know because I can see it. Doesn't mean you can see it. Sorry about that. It doesn't tell me what you can see and what you can't see. Okay, so secant of A is the hypotenuse over the adjacent. So the hypotenuse is H, which is 10 root 5. And the adjacent is X, which is 10. Now, hopefully you all know that 10 root 5 over 10 is root 5. Okay, so now we can say that secant squared turns out to be beautiful of A equals 5, because root 5 squared is 5. Any questions on that? Okay. So we now know secant squared. We don't know dA dt. That's the whole point, right? So let's write down what we know. I'm going to go back to this equation and plug in what we know. Okay, so 5 with secant squared times, and in fact, let me do it this way. Let me copy and paste it and then plug in what we know. Is always better. So secant squared of A is 5. dA dt is what we want. So obviously we don't know it yet. Negative 20 over x squared. Do you remember what x was?
10.
10. So x squared is 100. And what's dx dt? Seven. All right. So at this point, if you can't solve for dA dt, you don't belong in this class. What do we have to do to both sides? If you have 5 times something equals something. Yeah, divide by 5. Okay. And we get, again, I like to do the copy and paste and then do what I need to do to it. I want to divide by 5 on both sides. And I don't know, it just wants to kill a 0 here. And then that 10 becomes a 50. And that's equal to negative 14 over 50, which is 7 over 25. Or if you multiply by 4, it's negative 0.28. What are the units?
Is it radians?
Radians. I like what you said, Ricky, but not quite. It's radians per seconds. But if you want to have sex with the bird, that's your choice. Any questions on that? Okay, now do you understand my warning at the beginning of today? Have I done anything that you haven't already learned? Right? There's nothing here. There's no new calculus. Right? The algebra is what, Pythagorean theorem and like multiplying or dividing by 5 on both sides. I mean, what's hard is putting things together in a word problem. And that is tough. But honestly, I think all of you, that's the whole point. Okay. Really, I'm the only one in this group where that wasn't the point. You know why? What was my major? Hopefully, you know my major. And when I was in college, at least, and still. Yeah, my major was math. Okay, I think you could guess that, right? I don't think anyone said they were a math major. Math majors care about the math, and that's about it. But all the rest of you care about using the math. So today is the using the math day. And if you can't use the math, it's totally worthless for all of you. Does that make sense? So this is the purpose of this class for everyone, unless you decide to change your mind and be a math major. And then the purpose is the proofs and the, getting equations. Okay. Yeah, non-applied math. I was a pure mathematician, by the way. Pure math major. Very pure. Okay. So by the way, I have a lot of examples. I didn't expect to finish them all, but we'll do some. So let's move to the next one. And what I'm going to do, I'm going to do some copying and pasting. So I don't have to write the steps over and over again, but I can still remind you of the steps. It just saves time for today. And then I'm going to erase all the things that we did. But this problem, step by step, isn't going to be any different, as pretty much all of these problems are. Okay, so here's a new problem. We have a spherical balloon is increasing at the rate of 5 centimeters per minute. Find the rate of change of the volume when R equals 6 centimeters. Any questions on that? So hopefully you can think about this and imagine. Drawing the picture. We'll see if this actually works because it didn't last time. But I'm going to try drawing a picture. We have a spherical balloon, by the way, and that's all we know. So let's draw a little picture. Cross our fingers that it actually works this time. So do I have a sphere on this one? If I don't, I'll make one. No, it has cylinders, so I'll make a sphere. Yeah, it doesn't look good. That's better. Okay, so we got a spherical balloon. Now it kind of looks like a sphere. Best I can do with this program. And then let's draw the radius. Like so. Let's put in some letters. In this case, there's not a lot to put in. Unlike the last picture, what's the only letter you'd really need here?
R.
R. So let's put in R. Now I'm gonna hit save and cross my fingers and hope it works. Let's see. Yes, it worked this time. I have no idea why the last time it didn't. Okay, we drew a picture. Okay, and you can imagine blowing this balloon and it getting bigger. Okay, step 3, write down the derivatives, okay, that you know and the derivatives that you want. Okay, in this case, there's a derivative we know and a derivative we want. So let's read the question. Okay, and I think the key is the units. When you see the word per or a something per something, that's a derivative. Whereas if it's just a measurement like centimeters, it's not a derivative. But if it's a per minute or per second or per hour, that's a derivative. So we know that it's increasing. Spherical balloon is increasing at a rate of 3 centimeters per minute. Okay. So based on the units, this 5, what must that be? Centimeters. What must that be? We don't have a lot of choices here. Looking for a letter. What letter does that represent?
R.
Yeah, that's just R, and per minute means dRdt. So dRdt is 5.
Larry, are we gonna want to convert that into seconds eventually, or just leave it as is?
Just a minute. Did I make a mistake? Okay. Anywhere in this question does it ask you about seconds?
No, just the time. I mean, I figured the standard unit would be seconds. That's why I'm asking.
No, standard unit is whatever you want it to be,
Cool.
right? And in fact, for example, if you're doing driving, definitely don't talk about, miles per second. It's always miles per hour. So it's whatever you want it to be. You just have to make sure that if there's a minutes here given and some other place might have hours or something, then you got to convert. You have to be consistent. But as long as you're consistent, then it's fine. So we know that dRdt is 5. Okay, what we want is the rate of change of the volume. What's a good letter for volume? If you say anything but what I'm thinking, I'm going to be like confused on why you think that. Yeah, dV dt, and typically use capital V for volume, but that's up to you. Lowercase is usually restricted to vector, by the way. And that's what we don't know. Any questions on that? Okay, so now write down equations that come from the picture and the word that relate the variables in step 3. Okay, now our variables are R and V. Okay, and now comes your memory. You learned this in 7th grade, I believe. Okay, you might have used it since, maybe not. What's the relationship between volume and radius? I'll start you out. V equals. I'm all seeing you jump in. Yep, volume of sphere. Has a 4 in it. Has a 3. Has a pi. There we go. Yeah, 4/3 pi r cubed. There's the pi. Any questions at all on step 4? I want to give you a big warning. This is not that hard to watch me do, is it? Okay, and what's my warning? Okay, doing it is much harder than watching, just like kickboxing. Okay, so step 5. Step 5, and implicitly differentiate with respect to t. So with v, the derivative of v with respect to t is just dv dt. There's nothing much to do there. And whenever you have all kinds of different letters, use Leibniz notation. Do not use Newton's notation. Don't use primes because primes are confusing. You got to have letters in there. And then we're going to have 4/3 pi r cubed derivative with respect to t. Well, the derivative of r cubed is 3r squared, and the 3's cancel. And what you get is 4 times pi times r squared. And then we're implicitly differentiating with respect to t. So you got to multiply by dr over dt. Any questions so far? Okay, so then last is plug in the numbers. So let's go back to the sentence. So a spherical balloon is increasing at a rate of 5. Actually, we already have that. dRdt is 5. And we know R, find the rate of change of the volume, and R is 6. So R is 6, dRdt is 5. So now we just plug in. R was 6 and dr dt was 5. Okay, and this is boring work, but 4 times 5 is 20. 20 times 36 is 720. So 720 times pi. Any questions on this example? Okay, there's lots of others. I think what I'm going to do is I'm just going to hover for a moment because this is recorded. Did I hit record?
Yes, it's recording.
Oh, good. Yeah, if I ever don't, tell me. Okay, and that way you can practice these problems. These are some extra problems. So I'm hovering some more, hover some more, because we don't have time to do all of them. Okay, but I want to make sure you have them in case. I grabbed these from the book. I grabbed these from my lecture notes that I had, typed out. But let's do the last one, which I made up. Okay, you're driving on Highway 5, due south, in Sacramento, 3 miles north of the Highway 50 intersection. Okay, and your friend is driving on Highway 50, heading due west in Sacramento, 4 miles east of the intersection. Okay, so hopefully you've all been to Sacramento. If you live in Tahoe, you've probably been to Sacramento, and you've seen the intersection of the 5 and 50, and that's what it looks like. How fast are you approaching each other? Any questions on the question? You know what? I think, wait, you're driving on Highway 5 heading south. I forgot to tell you how fast you're going. So let me add some more in there. So you're driving on Highway 5 at 60 miles per hour. Heading due south in Sacramento, 3 miles north of Highway 50 intersection. And your friend is driving on Highway 50 at 65 miles per hour. Less traffic. Heading due west in Sacramento, 4 miles east of the intersection. How fast are you approaching each other? Okay, so the first thing is I'm just going to copy and paste the steps. Always a good idea to use these steps. This will get you through pretty much any problems in this section. And let me get rid of all the answers from before. Okay, so step 1 I just did. I just read it. Step 2, we want to draw a picture. Okay, so we're going to have a picture. And notice that everything is moving here. So there can be no numbers in the picture, but we're definitely going to have some letters. Okay, we have Highway 5. And notice that this will help. You're heading due south, and your friend is going west. Okay. So let's do this. And you're approaching. All right. Well, the first thing is I can draw the highways. Sometimes it's good not to be a good artist, because then I'm not going to even distract myself in like pretty trees in the background and all that. Those are my highways, and that works just fine. Got it? Okay, so there's my highways. And you're driving what direction?
South.
You're driving south, which means you're going towards your friend. So that means you're up here somewhere. Let's plot that point. And your friend is driving in what direction?
West.
Driving west. So that means your friend is on the east and going towards. Any questions so far? Okay, what's missing that I should draw? Very important.
Aren't you going the other way? You're coming from the east and going west.
I'm trying to remember what the question said exactly. Did it say I'm going west? Yeah, west is the other direction. Thanks. There we go. Okay, what should I draw now? There's one more piece of the picture, the geometry. Yeah, and in particular, I should draw the line segment going from my friend to me. And that will make a triangle out of it. Any questions so far? Okay, it's probably a good idea to get some variables. And let's be standard. How about calling that X? Sound good? If you don't know that standard, then I don't know where you've been. Okay, and let's call this guy Y. And let's call this one H for hypotenuse. It's the distance between you and your friend, but D is not a letter you should ever use in this class. Got it? So I'm going to use H for hypotenuse. All right, now we can save it. Hope it worked. It worked. Good. Any questions so far? Okay, now write down the derivatives that you know and the derivatives that you want. All right. So what's a derivative that I know?
I think you know the derivative of y and derivative of t, or over
Yeah, we know dy
derivative x.
dt, and what is dy dt is 60. It's actually negative 60 because we're going south. If it was north, it would be 60. So dy dt is negative 60. I'm going to make this a little smaller. That way we can fit it a little better. What else do we know?
Dx dt.
Yeah, dx dt is? $65, good. So dx dt is negative 65. Because x is you're going due west. So I think the easiest is copy and paste. And change that y to an x. Make that 60 a 65. There we go. Any questions so far? Okay, write down an equation that comes from the picture. You better all know this equation. Hint is there's no angle in this one.
Is it the derivative of h over dt equals the
It's an
Pythagorean,
equation,
or
not a differential equation. No derivatives.
what is it, the Pythagorean, or
Yeah, Pythagorean. So it's x squared. You better all know plus y squared I know you're used to A and B, but I'm calling it X and Y because it looks better. It looks like that on the chart. Equals H squared. Any questions so far? Okay, step 5, implicitly differentiate with respect to t. Okay, and this is the first time I've ever done exactly one of these types with those 3 letters, but that shouldn't bother you. What's the derivative of x squared with respect to t?
dx over dt.
2x times dx over dt, right? So 2x times dx over dt. And the derivative of y squared. That should be easy. Right, same idea. 2y times dy dt. And the derivative of h squared is 2h times dh dt. Any questions on that? Okay, last step, plug in the numbers. Oops. One more time. Okay, now it helps to go back and say, what is x? What is y? What is h? What are the derivatives? What do we got? So let's just say I see dy dt is negative 60. So I can take dy dt, turn that into a negative 60. I also have dx dt is negative 65. Okay, and then in the question, we're heading due south in Sacramento, 3 miles north of the intersection. Okay, so what is that? What is 3?
Y.
That's y. Okay, and notice that x is 4. So y is 3. X is 4. How do we get h?
Pythagorean theorem.
Yeah, and I was very nice to you. We have 3 and we have a 4. What's h? You shall have that one memorized.
5.
5. 3, 4, 5 right triangle. Okay, you could do the full Pythagorean theorem, or hopefully you know the 3, 4, 5 right triangle. It's the biggie, right? Okay, and we want dHdt. So now it's basic, boring arithmetic. So I don't know, maybe I'll just do this. So we have 65 times 2 is 130 times 4 is 520. And then plus 360, which is 880. So 880 divided by 10 is 88. So sorry if you guys are a lot faster than I am doing it in your head. What are the units? So what are the units? Yeah, miles per hour. Okay, and that's how fast we're approaching each other. Any questions on this example? I'm going to stop the share. I'm 1 minute later than I like to be, but that's okay.